Okay, so the end of next week is Railsbridge. We're going to be doing it here in the Edney. That's the 28th and 29th. The Install Fest is on the 28th, and that'll get your computer up and ready so that when you come to the workshop, you're just ready to go. If you came last year, you should still come again this year because we'll be doing the intro stuff, but we will also be doing multiple tracks. So if you're a little bit more advanced and want to do some stuff, you can come in and we'll have people to help you there with that. So you can sign up on bridgetroll.com and find the Chattanooga event. Also, shout out to Scenic City Summit. That's happening on the 28th during the daytime. So you could go to the conference and then come hang out at Railsbridge after.
There we go. There we go. Okay, any other announcements? Any other announcements? No? No? Okay. Well, we can probably do some afterwards. All right. So here's how this is going to go. We have HDMI and DisplayPort. So let's see. Our first speaker, Zach. Zach, you here? There we are. So Zach's going to come talk to us about Headless Chrome. I'll have you hold your applause for just a minute. Don't want to have an awkward moment between. Yeah. I'll be the cable swapper. Are you going to need both hands to type, Zach? Yeah. Because otherwise you get to hold the mic, or I can give you the mic stand. Okay. Here, we'll get this set up. Yeah? All right, give him a round of applause.
Okay. All right. So, intro. Headless Chrome. It is Chrome without a UI. There's no GUI. There's no Windows. It's just running Chrome features with no UI. So the first question is, why would you ever want to do that? What is the point? Well, before I do that, let me just give you a sense of what that looks like. So from your console or your terminal, you can fire up an instance of the Chrome application in headless mode, and you can go visit a website, and it will interact with it. So what can you do with this? Lots of things. First one would be automated testing. You can run unit test suites, regression tests, end-to-end tests, all that kind of stuff from continuous integration or locally without having to actually spin up the overhead of the Chrome UI. You can do stuff like PDF generation, automated screenshots, screen scraping, pizza ordering, all that kind of fun stuff. You can also run a REPL of Chrome's JavaScript console from your terminal, which can be nice just for without having to spin it up. Some nice things about that. So before I move on to like details about Headless Chrome, why does headless matter? I said a little bit before. With a no GUI, it's much more lightweight, so you don't have to have like for instance a Linux distro that has windowing capabilities. You can have a very tiny Docker container or an environment for running your tests that doesn't have the overhead of a window. Docker containers can be small, and your costs will be smaller for running your tests if you're running your own like cluster in AWS or something. So what are some alternatives to Headless Chrome? Obviously, automated testing has been around for a long time. You can do something like Selenium, where it's actually Selenium can drive. There's drivers for all different kinds of browsers, whether it's regular Chrome with the UI, Headless Chrome, Phantom.js, Firefox. You can do all kinds of drivers there. There's more overhead to setting up Selenium, and it's kind of a different approach. Running a headless browser is much more lightweight. Okay, before I go to this, so right now, probably the biggest, most commonly used alternative for Chrome headless use cases is Phantom.js. However, earlier this spring, Phantom.js was officially, they said, we're not going to work on it anymore. So lots and lots of JavaScript libraries, testing frameworks are built on Phantom.js. That's what they use to spin up a headless browser. But it's a ton of work. It's built against an old version of WebKit. Whereas like Chrome is now on Blink, totally different base, and the guy who's doing Phantom.js has been doing lots of good effort for years. But Phantom.js has lots of problems, but of course any headless testing framework is going to. But Chrome headless is basically directly tied to the core engine of Chrome, so you're running against what people are actually using, with Chrome having the insane market share it does. Okay, before I go to this, let's go do some demos real quick. Okay. All right. So firstly, let's spin this up. Is that big enough? I can try to make it a little bit bigger. Not gonna help too much. Okay. So what can you do with this? I could spin up Chrome. Basically, I've just aliased the Chrome application. Let me show this in my. You just go find it on your desktop. This is just for local testing. You can alias it, and then I'm running it in headless mode rather than just spinning up the application. So let's go do this. Open up a Chrome window, and now I can go to localhost. So this is basically just spinning up. You're like, okay, why the heck are you going to the debugger when you can just do that in a regular browser? It's interesting. Just you see, this is a headless. I have two Chromes. This is the headless one. This is just a web UI for debugging it, which can be useful when you're running your test to see, okay, because it is slightly different. It is a headless Chrome, not exact Chrome. It's a little bit different. But let's do something a little more interesting. Let's go do a screenshot. So common use case, if I want to do like a big desktop size screenshot, clear that out and paste. So this should output to, I'm doing squid.com. There are a lot of things on it. But okay, so open screen. Oh, come on, I have two things. Come on. Okay. So it pulls up, yay, I got a screenshot of the Squid website. It's pretty nice, pretty good fidelity. That's nice. You can also do some things like printing to PDF. That can be useful. The REPL mode, I'll just do this real quick. This is pretty cool. So like things like Phantom.js have this too, but Chrome's come with it. So I can go do, let's say, what was I going to do? Like I can check the location. Oh, I can't spell with my left hand. Go. Okay, so you get the location of the website. You can do maths. get your nice helpful maths. Okay. So there's a quick demo of some things you can do just from the application. I also want to briefly show, if I can, let's do node. So flipping over into here, I'm going to show using it to do some basic unit test running. So there's some plugin. So this is all very new. Chrome Headless is only released a few months ago. You can do some, you can programmatically control it from things like Node.js. So here I'm going to spin up an instance of Chrome using the Chrome launcher and Chrome remote interface, which just gives you kind of like access to the Chrome dev tools protocol through JavaScript. So let's spin this up. It's going to give me open up Chrome, give me the port, the user agent and stuff, and then I can navigate to a page. And once I'm there, let's just open this in the interest of time because I'm basically done. One hand, okay. Okay, now let's go fire this up. Hopefully this will work. Okay, so it waits for it to open. Gives you the title of the page. So it's basically opening up your page, and then it's going to go run a whole whatever code you want against the actual DOM in the browser. So what I did is I had it run a query selector call to get the title of the page. So you can basically evaluate any arbitrary JavaScript using the runtime evaluate library, get the result. So lots of cool stuff you can do. Also, let's see if I can do the one last thing, then I'm done. Okay, npm run watch. Okay, so this is going to run Karma. It's just like a test harness to run, whether it's Mocha, QUnit, or whatever. So it's spinning up some unit tests. So I have some really amazing unit tests for the array object. So just doing things, testing index of, and then I did a delay just so you can see it's kind of does some asynchronous stuff. And so it's running that in a Chrome headless environment using Mocha's test framework. So that's pretty easy to set up with. So like with Karma, you can set up the browsers to use. You could have it used like Phantom.js or Chrome, but here I'm using Chrome headless. So I would say, in conclusion, is it ready for use in your automated testing frameworks? I'd say not quite. It's still got some bugs. It's very new. You need to have good framework support for it. So, like as I said, like Phantom.js is used like in so many different frameworks and wrapper libraries right now. There's not quite that much with Chrome Headless out there, but it's getting there, and there's lots of energy behind it. So, thanks.
Ron Parker. Ron, you here? Ron? There you are, Ron. Come on up here and set up. Entertain yourselves. I am going to set a 5-minute timer this time. And it'll go off and you'll hear it. All right. Everybody give Ron a round of applause.
I was prepared to hold, but can everybody hear me okay? Okay. My name's Ron Parker. I do security architecture work for a big insurance company here locally, and I normally talk about security, but not today. We're going to talk about architecture today. So let's look at Ready, Set, Architect. We're going to talk about 300 seconds to architecture. And I was going to have a couple of slides. I ended up with about 60. So everybody kind of like take a deep breath and get ready, because I'm going to talk really, really fast, hopefully. So here we go. So like I said, I do this architecture as a living, and really this is not, you know, I have to say it anyway, not for the company that I work for. This is all Ron Parker, and you can kind of read down through there and see what it really says. But we're going to talk about why do we architect. We're going to talk about what are some of the frameworks, then how do I actually do this? What are the tools that you would actually use if you were going to do architecture? And when we look around the world, we notice that most things are things, and when we see one thing, a lot of times we'll see two things. And of course, the minute you see two things, we want to relate those two things one way or another. So what we're going to use as a quick example is Click Chat. We're going to write an application. Well, we're not. But we're going to talk about an application, Click Chat, because I want to be the next, you know, Zuckerberg and be the billionaire. So I'm going to talk about how I can put this application together. So I actually need it to be really resilient, really ready to go. So I needed, you know, a bunch of back-end processing to make it happen, so I can switch back and forth and make sure all that works. But so I don't have to do it manually. You know, what do? You put something that routes, something in there to kind of make it happen. So your Click Chat app always has something to connect to. And let the router go through and do its work and do whatever it needs to do. And as we start working through this, we slap a good hipster database on the back end that'll do our, you know, that'll do our work, and we can put it, and it makes us look really cool on our website that we use it. So that's there and ready to go. And what did we just do? What did we just do for the last 30 seconds that we were going through here? We were talking about resiliency, but there is no way I can do resiliency with just one piece of this. Because if I have an application, if I have an app, if I have a website, that's not going to give me the resiliency. I actually have to look at my entire application system from beginning to end to make sure I've got resiliency in all the different pieces that are there, including even the hipster application that's on the back end. So the reason we architect, the reason we do these things is because we optimize the whole. We optimize the whole and not just the pieces. That, if you walk away with anything else, walk away with this one slide knowing that when somebody says, hey, what do architects do? This is what we do. We make sure the whole thing works together. We don't give you the best whatever. We give you the best whatever that's supposed to fit into the big picture. So as we start looking at that big picture, we may bring in other people like engineers and operations and who knows what to look at what we're doing. And you can see we've moved to the cloud. We've labeled some protocols. We've done all kind of other stuff. Those are actually views. As we talk to different people, we can give different people different views so they can get what they need. And you can see that this went from very conceptual boxes to more physical things of where do we actually place things? What is, you know, what's the protocols? How does it work? What's a latency? I can talk about all that because I've laid this out in those different views for those different audiences. And believe it or not, we learned the first framework. We actually learned the GML. The GML is a galactic modeling language that everyone should learn how to use. It's boxes, lines, and labels. If you can't draw the system out with boxes, lines, and labels, chances are we need to, we might need to get together and talk a little bit. So really, it's all downhill from here. Any part of architecture is easy from this point out because we know why, and we know that we have audiences and views. And I know there's people out there shaking their head going, oh, this guy's, yeah, right. So audiences and views. So let's talk about other frameworks. C4 is a hierarchical framework that's out there. Has anybody heard of C4? It's a popular framework that a lot of people use. And this particular framework is really for software people. So if you're having to document your software, C4 is there because it actually it sets context, it sets containers to where we can talk about what's there. You can go down to the component level and relate things within there. You can look at classes or code, and that's C4. And I'm going to fly through several more because I just want you to know that these things exist. UML. You can use UML successfully. The thing that you've got to do is you have to pick out the good stuff, only use the good stuff, and ignore anything else that you think is not good. Otherwise, you'll be overwhelmed. And there's nothing wrong with UML. It has some good pieces to it. You just have to treat it like a wild cat. You just have to, So a couple of my favorites are class diagrams, sequence diagrams. If you haven't looked at, sequence are one of my favorites. Look at those things because they are helpful. Archimate. Archimate is an open group framework that allows you to do full stack modeling. It gives you motivation and strategy and technical and physical and all this great stuff. It has all the notation. It's a pretty decent thing to go out and glance at. So we've seen 4 frameworks. Now we need to look at tools. There are 2 types of tools. One's drawing, like paper. The other is modeling. Modeling is the more complex thing because it usually has a repository, is built for reuse, and allows you to build more complex pictures as you go along. First example of drawing, paper and pencil. Everybody knows that. Second one is Draw.io. Draw.io is online, completely SaaS-based. It's a great thing to glance at. And if you haven't seen it, you can draw anything with it. I recommend it highly. PowerPoint. How many of you have PowerPoint at your desk but you never use it? Okay, now you've got a galactic modeling language modeler tool. You can actually, it's a drawing tool, but you can use PowerPoint to do some decent stuff in. Same for Visio. Visio is not free, but a lot of people have it and they just never use it. Also, I'm going to point this one out. It does one thing really well, web sequence diagrams. You could take text, you write in the text that you want, it automatically generates a sequence diagram. And all you have to do is save that text and you can reproduce it at any time. Great deal. Plant UML, open source for creating UML diagrams. You can go to a command line, type some stuff, it will generate diagrams like you see there. Own the modeling tools, own the repository pieces, watch out for the freemiums. Sometimes the freemiums will not let you do certain things like print, so you have to be careful. There's Archie, which, oh, I'm gone. Archie, there's Eclipse, which is built in. There's Essentials, Sparks, and I wasn't going to say much about these anyway, and references. So anyway, that was 582 seconds to architecture, and hopefully go to www.secretchipmunk.com and I'll put a reference out there and you can pick it up from there. Anyway.
Next, we've got Camilo. Yeah, come on up.
Hello? Cool. Where are you, mouse?
All right, thank you. I'm Camilo. I'm going to be talking to you a bit about Vim today. Vim is a text editor, if you don't already know. It's not actually soap with the power of 100 lemons, but yeah, we're going to go over a little bit of the history of Vim, and we're going to go ahead and see some of the latest innovations in the Vim text editor, and yeah. So we start off in 1988. This is when Bram Molenaar started working on the Vim text editor based off of the VI text editor, which was a ubiquitous Unix text editor written in '76 by Bill Joy. So by this time, we've had 11 years of VI, and this guy, Bram Molenaar, starts writing Vim for the Amiga operating system. It starts out as yeah, kind of just a rewrite. So it starts out as a VI imitation. The idea being he wanted to bring his favorite text editor, VI, over to Amiga. By 1991, he had added so many features to it, though, they ended up changing that name over to VI Improved. So there's a lot of features that came out with Vim itself. Some of them like syntax highlighting, text completion, graphical user interfaces, and it's all very cool. And it remains just as ubiquitous at this point. It's been several decades since he wrote it, and everybody has probably used it in some way, shape, or form. Let's have a show of hands. Who's used Vim? Yeah, it's like the default text editor for Git, for servers. It's all over the place. On the other hand, who's using Vim every day as their coding environment? Less people, yeah. So personally, I started using Vim back in high school. My friend Brett at the time, he had a T1 internet connection and a computer running Debian Linux. So I would SSH into his computer and run my home page using Vim all on the command line because my connection was slow and this was a more consistent way of doing things. And I've been kind of in love with it ever since. No matter what, I keep on coming back to Vim because it has such great key bindings, such a great flow of text editing and so on, and great features. Now we fast forward a bit to 2014, where now we have NeoVim, and this is a relatively new project that sought to rewrite Vim, because as we said, it's been 30 years since well, almost 30 years since it was written, and it's gotten pretty old by this time, pretty stagnant. So NeoVim was supposed to be a complete rewrite and bring in a lot of new features without any of the old cruft that was there. One of the cool features that it brought along was asynchronous execution, and that's what we're going to talk about a little bit here. So the problem with Vim at the time is that it could, it's a strength and a weakness where it could go out to the command line, run any command, and bring that into Vim. That's a strength of running on the terminal, right? The problem was you had to wait for it to run. So for example, I have a file explorer. When I use Node with the way the NPM works, it has to go through 3, 4, 5, 7,000 files before it can actually display the list of files for me to go through. That sucks. Now with asynchronous execution in NeoVim, we can update the list that we have inside our text editor on the fly and yeah, have a more interactive experience and more things going through it. Spurred on by NeoVim, there was a big push in the Vim developer community to actually start writing more stuff and eliminating old cruft in Vim. So now there's kind of feature parity in this regard with the new version of Vim, Vim 8. So we're going to show off some of the plugins, or two of the plugins that use asynchronous execution really well. This is a plugin called Ale. So what it does is it plugs into linters and syntax checkers. And as you can see, what it does is it'll use a built-in syntax checker, so something like PHP's syntax checker, in this case, JSLint for JavaScript. And as you type, it'll give you feedback, like the little arrows on the side or the error that you get on the bottom. So he's doing errors on purpose, and that's cool. Another one is Kodi. So this person is writing some Python, and Kodi gives you a read-eval print loop, which is kind of like the interactive Python shell. In this case, they get to write whatever they want on the left side of their Vim text editor, and on the right side, it updates automatically with the results. Even as, we'll see them start from the top at this point. Watch the right side. So as they go through, whatever they do, even when they change it, it gets rerun, and the results are put back on the right side. They can write functions, import libraries, anything that you can do inside the Python shell, you can now do it in Vim and get those results right away. It's very good as like a scratch pad, test out ideas really quickly. So anyway, I've been thinking about creating a Vim meetup here in Chattanooga. If you would like to be a part of that, definitely come and talk to me at some point, and that's the whole thing. I hope you have seen Vim and you like it.
flawless timing. Flawless. It was on the dot. Yeah, another round of applause for that. And Brandon. Where you at, Brandon? Come on up here. HDMI?
Go. Can you hear me now? Good. So, hi, I'm Brandon, and I'm here to talk to you about the time type providers in F# saved me from fate worse than death. Hard for me, one of the toughest days of my life. With a little bit of functional programming, a little bit of courage, I got through it, and I'm here to share that with you today. So, can I use keyboard? No, I cannot. And why are we skipping slides? Let's just restart this because not even doing a demo, and we're having technical difficulties. So what am I even talking about? F# is a functional first language, fits in well with the .NET ecosystem. It allows for object-oriented constructs. It's not idiomatic, but you can do object-oriented development. Why is my machine flipping out on me? And type providers, Microsoft has a definition that may come up on the screen eventually. Basically, they're not an ORM, but they could play one on TV, where you might use Entity Framework, where you would otherwise use, in Hibernate or something like that. You can use type providers, you get your IntelliSense, you get compile time discovery of various constructs in your database, saves you a lot of time, saves you a lot of overhead. Not an ORM, you can read the definitions. Also, for more on type providers or F# in general, really, any functional programmer who's an F# enthusiast will be happy to talk about it. Actually, if you sit still quietly for about 3 minutes, I think most of us will start. Type providers, a lot of them are open source, a lot of them are up on GitHub. They're not magic. You can build your own type provider. In a lot of cases, they've already been built, but you definitely could do that. Not magic at all, just technology. So, ran into this problem recently. We are creating DNS entries for all of our databases so that rather than changing configs every time a server changes, every time a database migrates, you refer to database name .domain and you connect to that database wherever it is, and when it moves you only update the A record. Did about 160 of those recently. 3 environments, development, acceptance, production. That means you're running close to 500. And somebody said, hey, could you spot check a few of these to make sure that they're good before we release them to the ecosystem? Now, that's close to 500. The next time I tell this story, it'll be 1,000. The time after that, it'll be like 50,000 things that I would have to spot check. Not gonna do it. Developers are kind of selectively lazy. We wanna work on the interesting problems. Don't know about you, I'm not really interested in, hey, is this up? Also, this guy wasn't my manager at the time, later became my manager. He might not like me. I ran through a couple of things that were potential solutions. I could dump all these things into a batch script and ping every one of them. Well, okay, ping just tells me the machine's there, doesn't tell me SQL's on it, doesn't tell me the database is on it. Also, ping is disabled in my environment in a lot of cases. Okay, well, I could manually open up Management Studio and connect to, no, I'm not even gonna finish that sentence. Maybe I could write a program that opens up a connection, fires off a query, and then it struck me, no wait, F# type providers. So what I did, basically generated the type provider declarations from a list that I had that basically says, this is your connection into this database for all, are we up to 1 million now? For all 1 million things that I would have had to spot check. And if you look over here at the entry point, that's basically your default main method that an F# program gives you if you create a new solution. There's no logic. There is only declaration after declaration after declaration. And because at compile time, the type provider says, hey, check the server, do you have these structures? I just built it, grabbed a coffee, And when I came back, I had a list of here are the ones that work, here are the ones that don't. There were some older servers on the infrastructure. You have to have SQL 2008 R2 or better. And it said, hey, this might not be there, but I can't talk to it. It's too old. But in less time than it took me to talk about it, I had a complete list of everything. That's my story.
Killing it on the time. Love that. All right, so next up we have Adam. You ready, Adam? Boop, boop.
All right. Yeah, HDMI. So I have to say, if you don't name the Vim user group Vim users anonymous, I'm going to be very disappointed. All right, give me a second. Let's see. All right, so I do not have any slides, but I need to mirror screens. That would make things a little bit easier for me to see what's going on here. Okay, so who here has had to live watch a server log file or application log file on a system to try and figure out what's going on, to figure out an issue? Okay. Who here has heard the saying that less is more? Who here knows that both those two questions are related in some way? Okay, well, that was an interesting little thing. So, okay, how many people use tail-f to live follow a file? Who knows that you can use less to do the same thing with more features? So, less has a flag that's a +f that will live follow. And one of the advantages of less is you can use the Control-C to send an interrupt, and then it'll pause the live follow, allowing you to search the file for something, and then you can also resume the following as well. So to show that off real quick, let me do this, pull up another terminal window on this server. Yeah, give me a second. Actually, let me just tmux this. That'll probably be a little bit easier. All right, let's go up a lot more. Is that good? All right, so let me just do a split. So in here, let me do this real quick. So on this system, our logs are managed by systemd, so I'll have to do a little trick to do this. That's an internal application that we use at Uteliflex. So general CTL is a part of systemd to get the logs from an application, in this case our internal application, I'm redirecting that to a text file, and then I'm going to use less, and then I'll live follow that output. So this is going to be live following this file here, and it's probably not going to be the easiest to see through the tmux log, but if we trigger an event, it might be easier. And then I have a little script here that way I can fire off an event. All right, so in here we should be able to do an error search in the log now. So, I did the wrong flag. Hold on. It needs to be a capital F. But okay, so now if I do this, we should be able to search for error. Oh, let me try doing the resending. All right, so it's live following again. Let me resend that message. Come back up and rerun my search. Yeah, I can do that, but it's going to be error uppercase too. But I can do that too. Yeah. That. So if I do an upper error, I should be able to find that too. Yeah.
Give it up to Adam for tempting the live demo gods. Tempting them. Josh, let's do this.
This is just going to be a quick speed run through the concept of garbage collection, just to give an overview of that, since this is something that affects most people, but it's something we don't think about a lot. So what is garbage collection? Garbage collection is any algorithm that looks at the heap at runtime to determine when memory should be freed. And so the heap is this region of memory that is a little bit slower than the stack, and it's a bit more complex, but it's where objects are allocated that live for an unknown duration. The stack is a much faster region of memory for like local variables and that kind of thing in most languages, not including Java for the most part. And then you have two main types of, or you have an attribute of GCs that they're either compacting or non-compacting. So a non-compacting GC allows you to have lower latency because there are less pauses because you're not moving memory around. You're just saying, hey, this is available, or it's already being used. So The problem with non-compacting is that you end up getting heap fragmentation in long-running processes oftentimes. We actually had a talk from someone with Ruby recently actually discussing that. And then you have compacting GCs, which will copy the reachable objects to a sequential region of memory, increases your cache hit rates, and provides a number of benefits, like being able to free up memory back to the operating system. There are 3 primary types of garbage collection. You've got reference counting, mark and sweep, and generational GCs. So with reference counting, there's an integer tag on each object, and every time a reference is created, it just increments that integer. If a reference is destroyed, it decrements it. As soon as that counter reaches 0, the object is immediately freed. This has a few pros. This is a pauseless garbage collector. There is no latency due to stopping the world or any such things. And the collection is done in real time, so your memory footprint is pretty small. It's also the simplest algorithm that you can implement for automatic memory management, but it has some problems. Reference cycles can leak memory, and then because everything is happening as soon as you ask it to happen, alloc and free can be relatively expensive, especially compared to a generational GC. So planning is required around tight loops, not having allocations, and that kind of thing. You have mark and sweep GCs, which start with the known objects like local variables, function arguments, globals, and it marks them as reachable. It then finds any pointers in those objects, and it follows them recursively, marking objects along the way. After that, it iterates through the entire heap to free objects which were not marked as reachable. This has some pros. It's a simple algorithm to implement compared to generational GC, and it's easy to make it concurrent or incremental. So if you need to be able to guarantee low latencies, you can do that. The cons are that you must mark every object, whether reachable or not, which means that if your heap size grows, then your GC pauses, and the amount of time it takes to free up memory increases. And if you do concurrent or incremental, then you require more CPU to be able to do the same amount of work as a sequential mark and sweep. Generational GC is built around the concept that most allocations die young. And because of this, they typically are just an enhanced mark and sweep GC. So they just check newly created objects more often for whether they're reachable or not. As objects survive more GC cycles, though, they are promoted to older generation pools, which allows them to occasionally be checked for reachability rather than being checked every single time. This allows you to have less processor intensive time being spent and higher GC throughput. It's typically a compacting implementation rather than a non-compacting fragmenting one. So objects are copied from pool to pool, which allows them to be sequential, and that makes better life for cache hits and other stuff. But it does require higher latencies and longer pauses due to moving memory around and having to go update the references to that memory. And in some GCs like Haskell's, if you have long-lived allocations, they still get copied from pool to pool, which requires long-lived allocations to be more expensive than they should be. Just an overview of some collectors that are in use. You have reference counting with Objective-C and Swift. Python and PHP are both reference counted as well, but they have a mark and sweep collector, which is also used to break reference cycles. And then you have purely mark and sweep languages like Go and Lua. And then you have compacting mark and sweep implementations like Java's concurrent Marksweep. And that one is a hybrid between mark and sweep and a compacting generational. And then you have a weird one like Ruby's, which is non-compacting, but it's still generational. Generational is usually compacting. And then you have some other common ones like, yeah. Anyways, I hope that was a good overview.
I think this is going to be our last one. Where did that hour go?
Wave of the future.
Shout out to #DongleLife.
All right, I'm going to talk about PCG. It's a new class of pseudo-random number generators that is currently in pre-publication, not by me, by someone much smarter than me. But it was a lot of fun to learn about. So let's talk a little bit real quickly about pseudo-random number generators. There's a lot of things we care about. We care about statistical quality, meaning that we're going to get a nice, if we want a uniform distribution, we're going to get that nice uniform distribution over large amounts of random numbers. We want it to be very difficult to predict. That's very important to a particular industry centered in Las Vegas. And they've had a lot of trouble with that. We care about periodicity. So a lot of pseudo-random number generators will eventually get around back to the same random numbers. And so we want a very large period, or we want to be able to determine our period. We also care about performance. We don't want a random number tomorrow. We want it now. We want it yesterday. We want it as fast as possible, and lots of them. We care about how much space that random number generator takes up. It may take a lot of memory to generate a random number. We don't want that. We want a small amount of memory. And we want it to be simple. You know, we don't want some massively complex thing. We want it to be nice and simple to implement. And that's one of the places that PCG really works well in. It is fast. It has a tiny code size. It's statistically very great at generating random numbers for most things. And it's open source. It's got an Apache license, so it's really easy to see code and copy code. In fact, the one main thing with it is that it's not cryptographically secure. That means you should not use this for passwords or encrypting. That's a different class of random number generation and is generally much more expensive to do. Oftentimes, though, you're selecting a random on a playlist, you don't need it to be cryptographically secure. What song is coming up next, depending on what song. But the great thing about PCG, the PCG family, is that it is less predictable than a lot of the others. So let's take a quick look. This is the C source for a minimal implementation. That's it. It's pretty simple. It's a lot of bit shifting, so it looks a little crazy, but it's actually not that many individual operations. The actual the compiled code for it is also on the PCG's website and is also extremely short. It just doesn't take much to do. But basically, we have a transitional state function, which is here. So that's that first line right here. We're taking the state. We're going to advance the internal state of the random number generator, which gets the seeding of that state is not here. So we transition a state, and we also take in this case, the old state, and we have an output function which we apply to it, which is basically some nice bit shifting around to get that to work out. So what random number generator algorithm are you using? This is, depending on versions and whatnot, this is generally what you'd see. The most popular one there at the top, the mezzanine twister. A lot of them have switched recently. JavaScript recently switched around, and of course it depends on which implementation you're using there. And PCG, the authors of the PCG, have this wonderful chart which has them at the top, which shows all green, of course. They're not biased at all in how wonderful the PCG family is. And then other ones, you can see that, like, for example, the second one there is the one you'll find in PHP and Ruby by default, granted. And you'll see that it's fairly easy to predict comparatively, and many other things. So you can find out more about the PCG family. PCG stands for permutated current. I'm not even gonna try. At pcg-random.org, and I most recently built an Elixir implementation of it, which you can find on my GitHub. And there's not very many implementations of this yet, because the paper, even though you can read it, it's still in a pre-published state. So it's a great time to grab your favorite language, or your favorite language, or what will be your favorite language, and implement this. Thank you all very much.
Thank you guys for sticking around here. Very quickly, we've got a meetup tonight, right? What's it? Chattanooga Big Data. bottom line is you need to come. There you go. Modeling text with deep learning. Thank you guys for coming. We'll see you next week when Camilo is going to come out and talk to us once more. So come check that out.